Okay, we are moving on with our data analysis lesson. We're moving on to creating and analyzing frequency tables and stem and leaf plots. That's what you can do today. I will give you a data set, a whole bunch of data, and I'm going to tell you to make a line plot, and I'm going to tell you to make a stem and leaf plot. And with those, I'm also expecting you to analyze it, meaning tell me what the mean is, tell me what the median of that data set is. Not through ordering the way you typically do, you have to utilize the stem and leaf and the line plot. Okay, a frequency table tallies amount of time a term appears in a data set. When I say tally, I mean 1, 2, 3, 4, 5. That's what I mean by tally. You tick off how many times it appears. And if I tally and analyze the frequency of a term, I then can create a line plot. A line plot places an X based on the frequency. Well, let me spell it right. Frequency of a term. For example, if a number 1 appeared 5 times on a line plot on where the number 1 is, I would make 5 X's. I would say 1, 2, 3, 4, 5, like that. That's what I mean by that. So I tally, and then I create a line plot. So here's my steps. The first thing I do is make a frequency table. And then I make my line plot. So I want to know, I'm analyzing how many X's need to be on the line plot. So the first thing I do, well, let's read the question. A dice is rolled 20 times, and the results are displayed in this data set. I want to create a frequency table and a line plot based on that result. So I skim through and I say, okay, what numbers am I dealing with? What should I do to fill the top up? And if it's a dice, clearly it's 1 through 6. And now I want to start tallying. So I have a number 5, so I put a tally. A number 2, I put a tally. Another 5, put a tally. A 4, tally. A 1, tally. Do you see what I'm doing? A 6, tally. Another 5. A 2. Another 5. A 1. A 3. And what's nice about this is it helps me get things in order right away. I like frequency charts for this reason. Then another 6. Another 1. A 3, 4, 5, 3, another 5, a 3, and a 4. Woo. So I went through and I analyzed my data set. I made my frequency table, which just means what are the numbers I'm dealing with, and then tally how often they occur. Now I'm going to make a line plot. So a line plot just puts an X with the frequency it occurred. So I write my numbers down. 1, 2, 3, 4, 5, 6. Bless you. And then I just put an X however many times they occurred. So how many times did 1 appear? 3 times. So I put 3 X's. How many times did 2 appear? Twice. 3 appeared 4 times, so 1, 2, 3, 4. 4 appeared 3 times. So nothing too analytical here. 5 appeared 6 times. Let's see if I can fit this, because I want them to line up as well, because you want to be able to identify mode from here, so I'm going to try my best. 1, 2, 3, 4, 5, 6. and 2. And that's my line plot. What a lot of kids do is they skip right by the frequency table and create their line plot. They're like, well, I can, instead of tallying, I can just put an X where it is. And you're welcome to do that too if you want. Okay, Michael? Yes. No, go up. That's what everyone does. So go. So meaning like, yeah, start from the bottom and go upwards. Okay, and from this line plot, what is my mode? 5. Now we're not only analyzing mode, that's the easiest thing to analyze. We're going to do mean and median here in a second. Flip the page. I want you to do this next example. Okay, I went ahead and created the frequency table and line plot of that data set. And now given this data set in a frequency table, or the line plot, I am going to calculate the mean, the median, the mode, and the range. I'm going to go ahead and get the easiest over with. What's the mode? What occurs the most? 10. Okay, that's easy enough. Range. What's the range? Big minus small. 15 minus 10, 5. My range is 5. Mean. Add all the numbers, divide by how many there are. So what I like about the line plot is I can easily calculate some sums. So I have 1, 2, 3, 4, 5 10s, so that would be 50. I have 3 11s, which is 33, 2 12s, 2 13s, a 14, and 2 15s. So my mean is going to be 50 plus 33 plus 24 plus 26 plus 14 plus 30. 177 divided by how many terms? My terms equal the amount of x's. So I have 5, 8, 10, 12, 13, 14, 15 terms. 11.8. In my median, my strategy for my median, I kind of use logic a little bit. I know it's going to be somewhere in the middle, so I try to cancel off what I can. I have 5 values here and 3 values here for a total of 8 values. Now on the opposite side, I'm going to try to cancel out 8 values. 1, 2, 3, 4, 5. I can't, so I don't want to do that. But I can cancel out 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then you just do minimum, maximum. Minimum, maximum. Minimum is 11, max is 12. Minimum is 11, max is 12. I'm left with 11. So the key for median is you have to remember that you cancel out the minimum value and the maximum always, is what you're doing. Okay, so we did frequency table and line plots. Now we're going to use a stem and leaf plot to analyze data. A stem and leaf plot looks like this. So you have a stem, which is that outside number. Our stem is that outside number. And then you have this bar which separates the stem from the leaves. The leaves are the outside numbers. To analyze stem and leaf plots, what this really means is every number has a front number of 2. And then the leaf. So I really have 21 here, 24, 26, do you see what I'm doing? 2 and a 5, and a 2 and a 5. So what I did, they all had that 2 in common. So each one of these, I pulled that 2 out, and that became my stem. And my leaves are that second term. There's some very important properties with stem and leaves. There should only be one number on the leaf part, on that end part. Like if I have 312, then my stem would have to be 31 and my leaf would be 2. There can only be one number to the leaf part. Okay? Your stem can have more than one number. And it's a quick way to get data in order. That's the purpose of it. Frequency tables and line plots are quick ways to get data in order where you don't mess anything up. Let's practice stem and leaf, and then you'll feel more comfortable with the process.
We have 2 of that page.
Oh, weird. Me too. Okay, let's go here. So let's make a stem and leaf for the following data set. And then I want to find the mean, the median, and the mode. So I look to see what are the numbers I'm dealing with. It's 3 digits, so I know that my stem part needs to be 2. Because you can only have 1 digit on your leaf. So I have an 18, a 21, a 20, 19, bunch of 19s. So it looks to me like I should go 18 to 21. So I should have 18, 19, 20, and 21. Those are my stems. So what my stem is really representing, this is going to be in the 180s. This row is going to be in the 190s. This column or row is going to be my 200s. In this column, that last column is my 210s. That's what that's representing. Now I got to figure out what to put there. So the first thing I'm going to deal with is my 18s or my 180s. So I have a 189. Is that all I have? Oh, so it's 189. That represents 189. My next column is my 190s. So my 190s are, I have a 195, I have a 190, oh, I got a lot. I got a lot of them. So now I put them in order, and I just lost, I think I got it. So, my smallest 190s is a 190. And then I have a 192, so I would put a 2. I have a 193, so I put a 3. I have a 4, 2 5s, a 6, and an 8. So it looks like a lot of my data is in the 190s. Right away, I'm already making an interpretation on that. My 200s. It looks like I have a 200, I have a 201, a 201, a 205, and a 208. So I put it in order, so I have a 200, I have 2 201s, a 205, and an 8. And my 210s is my 211 and 214. Okay, I created my stem and leaf plot. Now I'm going to find my mean. I'm going to find my median and mode. Okay, mean is tedious. Mean is very, very, very tedious. What you're going to have to do, well, I mean, it's easy enough to go 189, but you could find the sum of each of these rows you could do, and then add them all up, or you could just start plucking away in the calculator. So what I would do is go 189 plus 190 plus 192 plus 193 plus 194